interrupted, but we're gonna finish this up. What are polyatomic ions? Polyatomic ions are covalently bonded compounds that act as ions. They act as a nonmetal or a metal in an ionic compound. So we've got NH4, ammonium. It's got an extra hydrogen on there that gives it a positive charge. So this acts as a cation. It acts as a metal in solution. What are some other ones? They're all listed in your book on page 245. Page 245. I think that's, I don't know, the only other positive one is hydronium ion. The rest are negative. So phosphate is PO4 3 minus. It acts as the anion, or the nonmetal, in an ionic compound. Hydroxide, OH negative, kind of the opposite of hydronium. Nitrite and nitrate. And these are used a lot in chemistry, especially in organic chemistry. Sulfate, SO4, has a 2 minus charge. So with these polyatomic ions, you just have to memorize what their charges are. Open the back door, let the kids in. Acetate is another one from acetic acid. Okay, you just have to memorize what their charges are. They're called polyatomic because poly means many, many atoms. Instead of just being a single atom like chloride or sodium, they are polyatomic. They have many atoms that form one ion. Okay? And when you put any of these in solution, they're going to break apart into ions just like any other ionic compound, but they're going to stay covalently bonded to each other. So this PO4 phosphate is going to stay together as one big negative ion. Okay? And it's a 3 minus. This nitrate is going to stay together as one big ion. It's not going to come apart into nitrogen and oxygen. It's just going to come apart from whatever it's with. So if it's sodium nitrate, it's going to break apart into sodium and nitrate. Okay? But these covalent bonds within the polyatomic ion are going to stay together. If you've got potassium phosphate, it's going to break apart into, when you put it in solution, it's going to break apart into 3 positively charged potassium ions and 1 negatively charged phosphate ion. So when you're calculating freezing point depression or boiling point elevation, I is the number of ions. For this one would be 4. Okay, for this one, I would be 2. There's 2 ions. For NaCl, I is equal to 2. Okay? Does that clear things up? So those are polyatomic ions. You'll just have to memorize. And by using them a lot over and over when you take organic chemistry, you'll just naturally memorize these. And if it's on your test at this level, it'll be given. Oh, and to find out, so if somebody tells you you have potassium phosphate, how do you know it's K3 PO4? You have to look at this charge and do it just like we do for any ionic compound. We know K is a 1+ because it's from group 1. We know PO4 is a 3- from our table on page 245. So then you just do the little switch. K3 PO4 1. If you had magnesium phosphate, we know magnesium's 2+ and phosphate's 3-. So then you have to do the little switch. You're going to end up with magnesium 3, and then phosphate is going to get a 2. So we need to put it in parentheses to show that that 2 applies to the whole polyatomic ion. So you treat that polyatomic ion like a little unit. Those covalent bonds in here aren't going to come apart in solution. Okay? And once again, the empirical formula and the molecular formula for an ionic compound are equal. So that concludes chapter 8 I didn't go over percent composition, because I think it's fairly straightforward. If they tell you how many, what the percentage of each atom is in a question, you can figure out how many grams and how many moles there are just by pretend everything's in a 100 gram sample, since it's 100%, 100 grams, to make it easy on yourself. So email me, call me with any questions about chapter 8, and I'll be happy to help you. And I'm going to move on to chapter 9.